Hi, everybody. I think we're ready to start the session. Thanks again for attending the NTI Sustainability Summit 2024. This specific session is obviously around 3D scanning. So we have talked about the agenda, but basically it's very down to earth how 3D laser scanning can support a sustainable agenda. And this is the breakout session part one. There are two others running right now, but I hope you have seen the full program of today and are ready for more after this specific session. So I'm Kenneth Mortensen. I'm business manager in the AEC segment at NTI Denmark, also working across borders with cloud solutions. You might know the Autodesk Construction Cloud. That's something I'm working with and in charge of, as well as infrastructure and scanning for AEC specifically. Bjarne is with me today. Bjarne, can you say something about yourself?
Yes, of course. Thanks a lot, Kenneth. I am a sales manager in the design and the manufacturing departments. So I'm, not working in the build industry, but working on design and manufacturing, and also supporting both the scanning environment and especially the plant 3D segment.
Yes. And you will see solutions today that will be specific for design and manufacturing and some for AEC, and some of it will be with principles from both worlds, as you can use laser scanning with the same objects, the same goals within both areas, I would say. So a lot of it taps into both business segments. Looking at the agenda and the topics we are going through today, we have some practical info. We'll talk about scanning in NTI, the hardware, why use scanning and sustainability, obviously, and we have a couple of customer case examples as well. This is just the topics we are going to go through, so it's not like a specific step-by-step agenda, but we will touch upon it as we go along. Regarding the practical info, you are all muted, but you can ask questions in the Q&A box. You can find that, I think it's in the lower part of the screen. The session is being recorded, and at the end of the session, we will answer the questions if we have enough time, obviously, at the end of the session. So please do not hesitate to ask them in the panel, and you can also do that at the end of the session of this specific one. Bjarne?
Yes, thank you, Kenneth. And oops, there I am. Okay, thank you. And just to follow up on Kenneth's comment about the questions, if we don't have enough time for the questions, we will of course answer them afterwards and make them available. Yes, but so what is 3D scanning? I like the headline here. It truly is unmatched precision and speed, and it isn't that difficult to scan. If you haven't tried it before, I can only recommend that you try it for various reasons, and some of them are stated below here. The 3D scanning from stationary equipment like the one we are showing here is very precise, and it enables you to make some complex measurements, whether it's an item you're going to scan, or it's a location, it could be a building from the inside, from the outside. And the scan can be used afterwards for comparing a reality. That's what we call as build, and then hold it up against the 3D model. It can also be used for great 3D visualization. I will get into later what you actually get out of the scan. One of the files is better than the other for visualization. It can be used for a flatness check. Flatness check is often used, like if you look at the picture here, for measuring the floor after it has been made, or to check if there are deviations that are not within the demanded tolerances. And it's easy to share the data afterwards. I will also get into what you can use to share with. FAO has some great tools for this. And especially within sustainability, it's very easy to revisit the site. You can do it virtually after you have the scan, and it is a 3D scan, so you can move around exactly as you do on a Google Street View. Below you will see the email address of both Kenneth and I, and you're very welcome to contact us here also. Kenneth, yeah, thanks. Okay. Again, a little bit more specific about the 3D scanning. What we typically see as the motivating factor for go for 3D scans is to get the correct measurements right the first time. It has always been possible to go out and do manual measurements with some laser tools or even a manual tape measure equipment, but it's frequently you will have to go back and revisit the site to do the measurements again. So and of course precision is also an issue, and also the overview by not using a 3D scanning is also not good. It's typically used for quality control and inspection, and it's also used, as I said before, for visualization with one of the files that you get out of the 3D scanning. And the goal is also to reduce or even avoid traveling. Of course, you need to be there one time, but it can be in the early part of the process, and you can avoid for the colleagues having to travel once more to the site. Well, when you are there, you can also reduce the time spent on the site because it's easier to get an overview on the scans. And after you have been there, you've done the scanning of a site, it's not necessary to go back and check and follow up again. And FAO has a very nice tool that actually helps you while you are scanning to get a good overview straight away from the scan. And then again, after you get back home, it's very easy to share the information also with the stakeholders that is not in the same office as you. What we're using when we're using the terrestrial scanner at NTI, we're using the FAO Focus scanner. It has just been updated here within the last couple of years. And just a few points about this equipment that we're using. It's called FAO Focus Premium 3D scanner. The highlights about the scanner is it's very easy to use. You simply start it up and you activate, you decide which sort of quality you want to scan in. And then you start up the scan. And while you're doing that, you can even watch it on your own device. It's a new feature that came with the Focus Premium scanner, and it's called Stream. So it basically means you can, with an iPhone or another phone, you can stand there and you can see the build-up of the scan from the location where you've placed the 3D scanner. You can also, via Wi-Fi, you can upload and start the registration straight away after you've done the scan. It'll save you a lot of time. It demands a Wi-Fi connection, of course. And after you've done that, it's actually already in the cloud, and you can share it with the FAO Sphere cloud software. If necessary, and especially within manufacturing where I work, it's very often important to produce some 3D documentation afterwards. That is possible if you make a precise scan, and that is exactly what the FAO Premium scanner can do. FAO has some nice tools here as well, and they are called FAO as built. It's an as built suite, so it can be used for both AutoCAD and Revit actually also. And a comment about us and our connection to FAO is that we are approved reseller for FAO scanners and also the software attached to it. We do also do scanning as a service, and you're also able to rent the scanner with our company, at least in Denmark. Please contact us for other locations around Europe.
And Bjarne, we also have a handheld device from FAO. Can you explain a bit about that and what the difference are between the premium scanner and the freestyler we have?
Yes, of course. And it's a good question because it's actually used mostly within manufacturing. This terrestrial scanner that you're looking at now is standing on a tripod, and it does a scanning, firmly in place, and it scans around. I will show it on a small picture afterwards. If you need to do some detailed scanning, maybe behind some equipment that is very dense with the pipes and the components and so, we have a handheld scanner where you simply walk around with the scanner and basically use it as you would use a painting roll when painting a wall. So you paint the object and the scan builds up. You will see it on your own device on the handheld scanner as well. And it can be connected to the scanning environment that you made with the Focus Premium also.
Yeah, so you might have areas where you're not able to use the normal laser scanner, and then you can use the freestyle scanner and attach those different scans together in one
exactly.
point cloud.
You need to be a little bit closer to the object, but by that you also get very fine precision on the item that you're scanning.
Exactly.
As I said before, a little bit about the 3D scanner. You can see it here in the upper right corner. That is the scanner placed on the tripod, and you're actually starting it up directly on a screen next to on the side of the scanner. This is also where you decide which quality you want to scan in, because you can do scans actually down to 30 seconds with also an addition from FAO on Flash. But most scans will take on the new scanner between a minute per scan and up to 4 minutes if you need a very fine quality that will enable you to do some exact 3D modeling afterwards. So when you start the scanner, it starts to rotate around, as you can see in the picture number 2, 360 degrees. So it shoots out a laser dot in all directions, and we are talking millions of dots, and it measures the exact distance towards the scanner, and it builds up a point cloud. At the same time as it turns around 360 degrees, you have the scanner head that also rotates, and as you can see, it rotates actually all the way around in a vertical manner, but cannot measure the last 60 degrees where the foot of the scanner is. But that's not an issue, because you will move the scanner to a different location afterwards, indicated by the blue dots here, and then of course you will cover the area where it was placed. The lower left picture actually just indicates if you have the black object in the middle and you want to scan it, obviously you need to place the scanner at these 4 locations, and then you will cover the object entirely. If you need to get details from below and so, you will simply lower the scanner down, and you can also raise the scanner. There is actually equipment where you can take the scanner all the way up to about 5 or 6 meters. So you don't have to walk around on the scaffolding and etc. This is an example and how it's typically used within D&M. By D&M, I mean design and manufacturing. So I divided it into what you get and where to use it. So what you get is 2 different files. You get what we call a point cloud. That is what you can see on the point cloud. And as you see, it's not just a dark image that it used to be. This is a colorized picture consisting of a lot of these small points. And that is actually what you're using afterwards if you want to do this 3D modeling, the exact 3D modeling, as I mentioned. The as-built tools I mentioned before from FAO, they can go in and spot various components like flat surfaces, like tubes, etc., and it will pop up with a suggestion saying, is this actually a DN200 tube, and this flange connection, is it this and that model? And by that you can simply choose that and very easily redraw the piping if necessary. This is not something you would do for the whole system, but it might be necessary if you're doing some retrofit and so, or replacement of a part. Then you can actually get exact points as you see on the lower right picture here. So you replace the point cloud with an exact 3D model of the pipe. If you look at the top right image, that is what we call a 360-degree image, and you can actually compare that to Google Street View. So basically, you can move from each location of the scanner to the next location, and then you will be able to turn around and see the 360 image from there. Yes, as I mentioned, it's used for on-site measurements, and it's quite handy if you want to do some retrofit, rebuild, or refurbishing. As an example, I can give within the marine equipment. If you have a ship and you need to do some refurbishing or replacement or reinstallation of equipment, they have been through some scrubber installations and also some other equipments on the ships. It's much easier to go out with a scanner at a location where the ship is placed. It can be in the harbor. You go down, you scan the room very precisely, and you can actually go home, produce the equipment, and you will make a perfect fit afterwards. It's either done while the ship is docked, or it's done in the harbor actually, and it'll save a lot of time. It's very expensive to have a ship in the harbor. As I mentioned also, it's often used for documentation and quality assurance. It can be documentation that is needed on some equipment you're shipping out. It can also be in the Kenneth's area within buildings, and so you need to document that everything is actually in the right space. And also for the next persons working on the building to check if the ventilation piping really in the right place, or did the blacksmith decide to put it somewhere else. Yeah. The argument about true as built. Oh, sorry, Kenneth.
No,
just want to
just
comment.
go ahead. Too fast.
It can actually be used as this is on a 3D drawing. You will see the 3D piping we have chosen to pull up here, but it could also be an orthographic overview on the drawing to make sure that everything is in fact as we have asked the guys who are producing it to make it. Yes, and then the virtual site visualization. By that I mean also on a ship, for example, or maybe an offshore installation. If you have this 3D scanning, especially the 360 degrees images, you can actually show this to colleagues or visitors that may have to go through a long travel, especially if it's offshore. Also some safety, very complex safety drills in order to go to the site. It's very simple to show how it looks like and do some training on the scanned file instead. By all what we talked about before, I think it's very easy to confirm that 3D scanning is a sustainable solution. What it can help you is reduce travel. It can also, resource the efficiency to make sure that people they don't spend unnecessary time. You can make a supply chain optimizations, and you can also extend the product life on some equipment. And then something that we call cultural heritage preservation. And you can help using existing building masses and basically reuse existing buildings. I will go into this in the next slides. Highly sustainable is what we call it. By reduced travel, we mean having it right the first time. So simply, when you've done the measurements, the control on site, you know that if you are in doubt, you can go to the scanned file and you can revisit it and make sure that everything is exactly as you saw it the first time. And again, you will do the revisitation virtually rather than traveling again. And if you pop to the right side, that is obviously where you can reduce the carbon footprint by less traveling. Resource efficiency by precise measurements. What we mean is that if you need to install some new components, like I told on the ship, you can prefabricate the components correct the first time. You don't have to say, I think it was, I thought I saw, and maybe it was this connection. You can always go back and you can do the measurements. And a 3D scanning is actually on a distance of 10 meters, it will be below 5 millimeter in tolerance, very often close to 1 and 2 millimeter. That also helps to avoid the faulty installations due to these missed details. And that also takes you to the right side and enables you to reduce material waste or consumption. By supply chain optimizations, we're talking about avoiding the unnecessary transportation of parts or prototypes that you need to go out and put on a location to make to check, does it fit now? Was it the right one? Was it placed in the right height, etc.? And then a product life extension. By that we mean if you do reverse engineering, you can extend the life cycle by repairing what you have scanned. It could actually be also on a ship. It could be a part down to a specific parts in a gearbox that you can't disassemble on the ship. You can do scanning of the parts, like Kenneth said, for example, with the handheld scanner. So if you have it damaged to, it could be a gear wheel or something, you would spot the damage to the gear wheel and you know exactly what to do when you go back to the repair shop where you may have the drawing, and then you know how the damage occurred and how it looks on site. and that is, as we write here, rather than discarding or replacing the entire product because it's not feasible to repair it on site. Then you can simply bring the new part out that you manufactured and install it on the site. So my headline in the bottom is actually thinking and acting sustainable. It very often reduces costs. This is a different area. As I say, this is still highly sustainable, and it's not only in manufacturing. The cultural heritage preservation, I think we have a good example to the right. This is a church in Copenhagen that we were asked to do some scanning on. This is a good way to preserve the artifacts instead of having to go and measure it and keep touching and keep measuring with the hard tools, etc. And then, of course, you avoid the physical handling and transportation. It could be a statue that needed to be measured and documented. You can leave it where it is, and then you can build up the model afterwards. And what you see to the right is actually a point cloud where we have created a mesh afterwards. It did demand some cleaning of the point cloud before we were making the mesh. But the mesh is actually performed in an Autodesk program called Recap, which many of our customers with Autodesk products already have. So there are some strong tools from Autodesk also supporting 3D scanning. And now I'm actually slowly going over to Kenneth's area by this reuse of existing buildings. By that we mean that it's easy to visualize a complete building and maybe use the building for a different purpose. In some cases, you may not, or the decision makers may actually decide to reuse the existing building instead of tearing it down and building new buildings. And that is actually what we see more and more. We've seen small companies actually specializing in this and just doing some optimizations on the insulation and etc. and then just reuse it. Thanks.
Perfect, Bjarne. A great example of how you can also use laser scanning with preservation. So a lot of what Bjarne has explained so far is something that taps into both areas. And by both areas, I mean AEC and design and manufacturing. So what I've done is taking a couple of examples of what we have done for customers in AEC specifically and how we have used it in that respect. So a bit about point cloud utilization and capturing data. So this project specifically is for a large real estate owner in Copenhagen called Jordan. I think they have a bit more than 200 different properties, so one of the large ones in Denmark as well. So we used a couple of different solutions for this one that was necessary to kind of get through the whole task, so to speak. So we used the Faro focus scanner, as we have already seen. We used a drone to capture data and photos from above the building instead, because it would be quite time consuming if we were to scan it all from above and the facades and so forth. And what we did was actually we data merged these into one model. In order to do so, you need someone who is pretty specialized in that kind of workflow. And we had Jens Hellqvist as project lead here. He's a consultant and surveyor, specialized in infrastructure, 3D laser scanning. He's a drone pilot as well, which you need to be in order to do these kind of tasks. And he is also capable of using Faro software, Civil 3D, Recap Pro, as Bjarne just mentioned, Revit, InfoWorks, and so forth. So he is one of the good guys in this area. What we see here is another picture from above, and we have several ways of capturing data, but also of storing data and visualize it in different programs. So Recap is one of them. We can also use Autodesk Construction Cloud, which might be known to a lot of you out there, which is a project management tool. But there are different ways of doing that. But just ask, and then we will explain the opportunities here. So what we did was actually, before you start with a project like this, you have to do a lot of planning. So it's not just about taking a drone and do the flight. You have to have the right things in place, so to speak. You need to be allowed to do this drone flight. So we need to have that drone pilot. In this specific case, we had an embassy in the building as well. That basically meant restrictions a lot of the time. So we could only fly like 15 minutes at one specific day to do the capturing. So that was one thing that we really had to take into consideration. We also had to block the traffic in the streets. That was on the other side of the building you see on the left. So a lot of things you have to take into consideration when doing this. Furthermore, we had the laser scanning as well. You have to plan everything inside the building. On the right, you can see Jens working with an iPad. You have to have a good overview of the whole location, where to do the setups, to have that, one thing, or you want to do it all on the same day, collect all the data the same day. So you need to have a good overview of the site to capture all of the data necessary for not going back again, as we want to avoid. This is something that came out of the one model point cloud that we created. So this is a view we have in Recap Pro, which is basically the intermediate solution to take the point cloud and put that into the next solution or product. So that could be Revit or Inventor, Plant 3D, Civil 3D. So that's a good view of the whole situation here. And another way to look at a facility or location is this way, to have that scan with the interior overview, which is really good to have a discussion around, to have a dialogue with the building owner, with the project stakeholders, to see what is the situation here, what do we need to be aware of. This specific capture is in Revit, where we have the point cloud in Revit. And from there, you can actually build the model itself, the BIM model. Sometimes it's not feasible to do that, because it does take a lot of time to create a BIM model also, even though you have the point cloud. But in some cases, you do want to digitize it all, have the information stored, and build a 3D BIM model in Revit, and then build it from there. So that's an example of that. This is not the exact same building, but it's a great view on a building with a lot of different details that demands. It's a really good situation where you want to have 3D scanning to have all the details captured, so to speak. If you don't have that, you will have to take a lot of measurements with measuring tape, laser distance meters, have to go back and forth. So it's a great example of what Bjarne also told you earlier. We want to avoid all the traffic emissions and going back and forth, spending resources, man hours on this, etc. So that's a good example of that.
And can I just break in just shortly, because I
yes,
forgot
definitely.
something right before you indicated one of the point clouds that you were showing, and you told that you can look at the point cloud in various programs, and you mentioned a few one. One thing I was just notified about from one of our consultants is the point cloud. You can actually make some clash detection directly on the point cloud, which is actually quite a good tool.
I will get back to that in just a few,
okay.
actually.
Fantastic.
So, but that's a good point for those guys of you out there who has Navisworks, for instance. So really good one. You can obviously avoid doing mistakes in the construction side, or capture it earlier anyway, by using the point cloud versus the design model. So that's a good way of working as well. Good point, Bjarne. We did use one other scanner, a Matterport scanner, and it's not very accurate or precise, but what it does really well is to do the visualization, and it's really fast at doing that. So if you just want to have a visualization of the location, go through it point by point, that's also a good way to do it. It just captures a lot of focus and stitch it all together in a nice way, so you can actually visualize it efficiently. What we did in this specific case, we needed to have the ground floor mapped and digitized. So we created a BIM model of the ground floor from the drone data. And in this specific case, we used Ferrocene, Recap Pro, Revit, and Faro As-Built. Faro As-Built is a plugin in Revit, for instance. Could also be in Plant 3D as well. But it in this case, it enabled us to build the walls, the floors, the windows, the doors very, very fast in an automated way. So that speeds up the process quite a lot in that modeling process. And another example we have here is you can see the ground floor that that has been modeled, but you can also see the point cloud on top of that. So it's just really easy to build the model from that point cloud when you have them stitched together like this. So you can quite easily build it. You also have to look at the detail and so forth, and there might be obstacles in the point cloud as well. But it's way easier to do it this way when you have the situation in the point cloud. Visualized for you that way. It's also, in this case, it was really good to have it as a QA during the project execution when they had to rebuild it, so they could actually do the scanning as well on site when they rebuild the whole ground floor. And then it's good for documentation as well. This specific example is exactly what Bjarne also talked about just a few moments ago, that you can have the scanning and the design model stitched together, so you can visualize is everything as it should be according to the design, or have they installed something where it's not supposed to be or not within the tolerance. So this is a great way of making the quality assurance in the projects out there. So customer outcomes in this case was material waste reduction in renovation, better visualization, definitely, faster design and planning, and then it reduced travel time and carbon emission due to less transportation. So for them, it was quite obvious to move forward with that. Another case I have is a large hospital in Denmark. That's the Odense University Hospital. We have quite a few of those we call super hospitals in Denmark. The old ones are, worn down, so we need to have some new ones to have a better health situation, so to speak. So this is 284 square meters, 4,000 square meters, that is 833 new patient rooms, 52 operating rooms, and 374 outpatient clinics. And the primary objective of this was to use 3D laser scanning as a continuous quality assurance to minimize errors and avoid conflicts. And I do like that about avoiding conflict, because if you catch it earlier in the project phases, it's easier to have a conversation around it. It's visual, so that way they actually were able to capture it before it went into a specific conflict. It was really good for them to do clash detection with the MEP installations as well. So they need to be installed, with high precision, and to avoid collision, it was really good to have laser scanning to capture that as-built data as they were moving along. So these are the two guys working with laser scanning at OUH. It basically gave them a more efficient QA process, including clash detection, less rework as they find issues early in the process. So that has also led to reduced material waste because they were able to catch it early in the phase. Better visualization for the site, leading to fewer conflicts and errors, and high quality documentation. But one other thing they use it for is also facility management, which was a new way of working with it. So they could use the laser scanning to obviously digitize the old buildings, and the point cloud itself made it easier to plan maintenance requirements. They had the visuals, and sometimes you don't need to build the whole 3D model in Revit or wherever you want to do that. You can just use the point cloud itself to plan and have a conversation about what needs to be done. So they were definitely going to use that as a really, really nice tool and a kind of digital twin in the facility management way of working future-wise. So if we have a little recap around it all, again, fast visualization of structures, including precise geometry, always comes in handy. Easy documentation, efficient Q&A process, including as-built versus design. So we have less rework, leading to reduced material waste, less transportation and time used as you collect all data and measures the first time. Traditional methods are typically more time consuming, working with measuring tapes and laser distance meter and so forth. That is something that takes a lot of time and multiple visits to the job site. And you can also optimize on energy when you have the known geometry. And if you don't have that, it's really good to use laser scanning to do that digitalization of the building. Then it's easier to do the design and planning of a construction and, for instance, ventilation and so forth when you have the right geometries. And one last point, everybody's talking about digital twins these days, and you have a lot of opportunities with laser scanning here. So laser scanning is a good way of digitizing the building, and also update the digital twin after the renovation task is done, for instance, or after you have done new installations in the factory or whatever it could be. You need to update it always, or else it's not a digital twin. You want to have that one-to-one of the real life. That enables you to simulate, predict, and inform you about your construction, your building, your processes, and so forth. This way of thinking also enables you to do that. So I think we are through it all. Bjarne, do you have any final comments before going into Q&A?
No, I think we have covered it all. So I think we should open up for the Q&A session right now.
Perfect. We'll do that. Thanks a lot.
Thanks.
Keep asking questions.
Okay, Kenneth, I can start out here. We have received a few questions. As a matter of fact, I'm happy to see that our guests, they seem interested in getting started. One of the questions I received was scanning as a service. I did mention it earlier that it's possible with us to hire us to come out to the site and do the scanning as a service for you, and also do the training on site so you can learn how to use the scanner, and eventually borrow the scanner or rent the scanner from us afterwards. We have 2 locations in Denmark where you can rent a scanner. It's Aarhus and in Copenhagen. And I know in Norway, we also have a location that has a scanner that is possible to rent. It's located in Sandvika in Norway.
Yeah. We have a few more questions, Bjarne. One is pretty straightforward. Is it expensive to to own a scanner or to buy a scanner? Huh. Do you want to answer that one, or should I?
I can give a few points there. Renting the scanner is not expensive, and if you want to use us for the scan job, if it's, for example, a building, let's say 200 square meters, you need to have scanned with a relatively not a lot of specific equipment inside. It can often be done in half a day. So you can rent NCI to pop out for half a day and do the scan. And I would say the registration and gathering of the scan afterwards will take about the same. So approximately 1 day, and then your colleagues or yourself can then be trained in using the scanner, and then you're able to rent the scanner afterwards. If it's a matter of purchasing a scanner, the scanners come in many variations. Our scanners are quite precise, as Kenneth mentioned. If you can go down and buy a Matterport scanner, it's very good for visualization, but not that precise. Our scanners from Faro, they range at about 15,000 euro up to 50,000 euro, depending on the purpose.
Yeah.
But please contact us, and then we can go into the specifics. Our email addresses was at the beginning, and they are very simple: KSM for Kenneth and BT for myself at nci.dk.
Yeah. We have a few more questions, Bjarne. So one is, can you elaborate on the high and low resolution scans? What is the difference in, for instance, file size?
It is correct. The more precise you make the scan, the heavier the file size is. And to be honest, I don't know the exact size. They can be quite large. So basically what you do when you make these scan files, the point cloud, etc., you either store them on a micro SD card in the scanner, just an SD card, or you can upload right away and then go home and work on the file. You simply upload it to the Faro Sphere software, and you can work on it afterwards. And if you want to share the files, it's typically done via file share, etc., because they are quite large, the files.
Right. So not only about the resolution, it's also about how many setups do you do, for instance, how much do you want to stitch together and so forth. But it can demand quite a lot of server power. So that's something you need to take into consideration. Yeah. What is the best software to use for scan to BIM? What is your experience? Yeah, that might be in the AEC area here. So different ways of doing that. you capture the scan first, have the point cloud stitched together. We use some Faro software for that, which is obviously good for that kind of hardware. But after that, we can use several different solutions. Revit will be one. We use Faro as-built to kind of construct the whole BIM model faster. But it also depends on how far do you want to go and how much do you want to automate. So there are different ways of doing that, but it's actually quite straightforward. So you need, have Faro Scene, Faro Autodesk Recap, you need to have Faro as-built, you need Revit, for instance, as well. So that's one way of doing that and having that process.
In order to take the file and pull it into Revit, you need to take it through Recap. That is the Autodesk way of doing it. But again, as I mentioned, the Recap, very often our customers has a Recap already, because if you both have a Revit and AutoCAD, it doesn't make sense to have those separately. You normally buy the collection package called the AEC collection, and in that one you have Recap Pro. It's the same for manufacturing, where you use Inventor. If you also have AutoCAD or other programs, you will typically have the PDNM collection, and it also includes Recap Pro, which is also a strong tool for handling the point cloud by itself.
Yeah. We have just 2 minutes left, Bjarne. So next one here is, how about point clouds and virtual reality, augmented reality?
Yeah,
we have tested quite a lot, I would say, with different goggles, seeing how far we can go. Bjarne has done that quite a lot.
Yeah, that is our scanning colleague. He's done that, but it's fairly new to us. But we have customers using augmented reality today, actually, using them in models. I did mention it earlier on. Rather than going offshore on offshore locations, then you can actually train your colleagues at home instead of having to travel offshore. And they are using it's actually not augmented in their case. It's more like virtual reality, and that is also very feasible. What you normally do is use the scan file or the point cloud, and then you build a 3D model where you can move around in. But there are different programs, and Autodesk also has solutions, but it's quite new to me, so I need to involve a consultant for that.
Yeah, so we have tested, we're creating issues in VR specifically to take that issue or that commons the data back to Autodesk Construction Cloud, for instance, so it's directly attached to the project platform as well. So that makes sense. We have a comment here.
Yeah, it's Justin Taylor, actually. He just gave us a lifeline. That's good. So he said
exactly.
You can view the point cloud in augmented reality, but I would suggest converting to a mesh. So converting to a mesh, if you can automate that, that's of course easier than doing the 3D modeling. And actually, Justin Taylor, he mentioned, I think it was point views using to create the mesh. Quite efficient way of doing it. Thanks a lot, Justin.
Yeah. So I think that was it for now. We have half a minute left. So from our side, thank you very much for watching. And get back to us. You have our contact info. So please, have any further questions, just reach out.
Thank you.
Thank you.